everyone, welcome back, and in this video I'll be giving you some information on data mesh. So if you have already heard about data mesh or you even haven't come across what a data mesh is, here is some information about it. So let's get into it. So before we go into understanding what a data mesh is, let us first take a recap of the evolution of data platforms. So the very first we have the data warehouses. So data warehouses initially they can only manage structured data, and some of the drawbacks of the data warehouses is that it's very costly to implement because getting that data to match with the target location or central repositories schema is very costly and requires a lot of time and effort. Also, it cannot handle unstructured data. So in order to overcome these drawbacks is where the data lakes came in, where they can accommodate structured, semi-structured as well as unstructured data. But of course, data lakes also, they have their own set of drawbacks, which is it does not provide asset properties, and also failing to organize that data would also lead to data swamps. Lack of data consistency prevents security of sensitive data, so you're not able to implement any security rules to this data. So these were some of the drawbacks. So with these data platforms, if you see the very underlying architecture is that these data platforms maintain a central repository. So when data is collected from multiple sources, it can be any type of data, structured, unstructured, or semi-structured, depending on the type of an architecture that's being used. These data are collected and then it is transformed in a way that it can be stored in a central repository. Okay, so that's where ETL comes in. So if you want to know more about what data warehouses are, how it differs from data lakes, if you want to know that, I've taken a video. I'll add the link in the description box. Also, if you don't know what ETL is, I've taken other videos on ETL, so you can refer that. The links what I've given in the description box. So coming back to this topic, so all this data gets stored in a central repository from which consuming applications or consumers can consume the data. So if you see, the issue with this central repository is that it cannot, I cannot say cannot, integrating new sources is very tough. Okay, it's not very easy to just say, hey, you know what, I have this new source that from which I need data. You integrate it and then the data keeps flowing and gets stored in the central repository seamlessly. That doesn't happen. It takes a lot of time and effort that needs to be done to manipulate and to alter and build the pipeline in order to accommodate that new source. Also, another issue with that is scalability. Scalability in terms of volume, geographic scalability can be issues. Also, it's a single team ownership, so this entire process, this entire setup is taken care by a stakeholder team, okay, who needs to manage this entire pipeline, manage the repository, the warehouses, etc. So this is another issue, as well as maintaining this entire thing. It takes a lot of time, cost and effort. So these are some drawbacks with this central repository. So having these drawbacks is where data mesh comes into the picture. So what is a data mesh now? A data mesh is a decentralized data architecture that organizes data by business domains. So if you're wondering what business domains are nothing but functions or departments in an organization. So domains can be, for example, finance, marketing, sales, HR, etc. So the entire key note or a point to focus on this data mesh is that it's a decentralized data architecture. Okay, so this central repository, okay, is no longer required. So this entire setup is being decentralized into business domains. So every business domain is going to take care of their own domain data rather than these business domains being integrated and getting stored as a central repository. Okay, so I hope that you're getting this point. So keep in mind, it's a decentralized data architecture. So every domain now takes the ownership and responsibility of their domain data, integration, maintainability, and easy accessibility for other teams. So rather than all the domain data is getting extracted, then you transform that data and load it in a central repository, and one single team maintaining this entire process. This is going to be taken in charge by every individual data domain. Okay, so every individual data domain is going to extract data from their own sources, okay, relevant sources. They are going to transform and load the data and make the data available for other consumers, so that ownership is being transferred. To get to know more about what data lakes are, we need to check on the principles of a data mesh. Okay, so this data mesh has four principles. The first one is domain driven ownership, data as a product, self service infrastructure, and federated governance. So now if let us see in detail what each one are. The very first principle is domain driven ownership. So by the name itself we know that instead of a single team taking responsibility and ownership over this entire pipeline and this entire setup, now it's going to be shifted from a single team to domain driven ownership. So every domain, as I said, is going to take in charge of their data. They are going to integrate data from multiple sources where their data comes in from, and they are going to transform it, load it, and make that data available for other teams, what I said earlier. And each domain, they know their data best. So why did this exact ownership come into picture? Imagine data being integrated from different domains, and then you have to store it in a central repository. This entire setup is being taken care by a single team, which is the warehouse team, or you have stakeholders. Now they would not have expertise on every domain data. Okay, so it's a costly affair also. So the best thing is what was done is that this is being decentralized, and every data domain takes care of their data, because they know best how to manage their data, where does their data come from, and how they need to store their data, and for what purpose their data gets used. So with keeping in mind all this is why every domain takes in charge of their own data. So that was the reason of transferring of ownership. So they take ownership of the data integration, maintainability, and easy accessibility for other teams. So by decentralizing this, now this might come up in your mind, where will there be any chances of data silos? So to answer this question, we need to go through the other principles. So the second principle is data as a product. So now you would be thinking, what happens now? Does every team maintain their own data, and do they make use of their data? How does other teams consume their data and stuff like that? So here is the answer to your question. So every domain, okay, let's say for example, there are different domains: HR, sales, marketing, finance, etc. So every domain, as I said, they maintain their own data and they take in charge of their own data. So the main idea of data mesh is that this data mesh concept makes teams think of their domain's data set as products. Okay, so the data, you just don't see data as data, you see data as a product. Why? Because let's say for example, to do analysis, to take certain decisions, to make certain recommendations, we based on data, we would be able to perform those operations. So data itself is a product, because there are people who are consuming that data for different business purposes, for different business cases. So data itself becomes a product, and when you have a product, by default there are certain consumers of that product, so there becomes customers of the product. So when you take this entire landscape, domains, they produce data, and that data is going to be a product, and other domains that are going to consume that data, they become the customers of that product. So that's the main mindset that needs to come into picture when you're dealing with data meshes. So for example, if you see here, we have the HR department. They are a domain. They have their own data. Data comes from multiple sources. You have job portals, you have other sources, you have like other external or internal sources, applications from which they collect their data. They transform and they load their data. And now they have certain data sets. So that data set, of course, that data might be required by other domains. Let's say, for example, the finance and the IT domain. So they need to consume that data. So the finance and IT domain, they become customers to the HR data set, which acts as a product. So that's data as a product. So also, you might be thinking now, what happens, how does these domains, how do they operate? Is there, like, a separate governance that each team follows, or stuff like that? So the answer to that question is also, domains need to adhere to a federated data governance standards. Okay, so there's no separate standards that every domain followed. There is a universal governance that is put in place, and that needs to be followed by every domain. Okay, and also, now when data is a product, we expect certain qualities and characteristics from a product. Okay, you buy any product, you expect it to have certain characteristics. It should be, might be reliable, durable, it should be secure, stuff like that. So when data becomes a product, there are some characteristics it needs to fulfill, and it needs to um, comprise of. So some of those characteristics are that data needs to be discoverable. They also need to be high quality, reliable, and trustworthy. Discoverable in the sense it needs to be available to other domains so that they can consume that data. The data quality needs to be high. If it's going to be of low quality, there's not going to be of any value of domains consuming that data. Also, the data needs to be reliable and trustworthy. Okay, if it's not going to be trustworthy, again, no value. You cannot make any decisions or recommendations on that data. So these are certain characteristics that data needs to adhere to. So with the next principle we have is self-service infrastructure. So domains can operate without having to worry about infrastructure resources. Okay, so every domain, they would have, as I said, they have their own ETL pipelines. For these pipelines, they definitely require infrastructure. So they don't have to worry about that, whether they have the necessary resources or not, because there is going to be a shared infrastructure in place that is going to be shared with every domain, okay, in that particular architecture. So infrastructure over here is acting as a service. And also there's going to be universal governance. Okay, so teams, they don't have to have separate governances over their infrastructure. For all these pipelines running, there are going to be certain governance standards put in place. So that is what is meant by self-service infrastructure. And the last principle is federated governance. So data, if you don't know what federated governance is, data governance standards that are defined centrally. Centrally meaning the main global governance team, but the local domain teams have the freedom and resources to execute these standards. So as I said, the rules and standards are fixed by the main global team, and those standards are going to be followed by every business or data domain. Okay, and they also have the freedom, okay, of using those standards in a way that best fits their particular use case. So if you see, what are these governance standards, some of them can be data quality. So definitely they all have to maintain a certain amount of data quality so that it can be used by other consuming teams, which are customers. Also access controls, this is very important. When data is in a central repository, there are some access controls as to who can access the data and what type of operations they can perform on that data. Now, the same set of access controls will be followed when it becomes decentralized. So, there's no, what to say, extra privileges or less privileges when it's being decentralized. So, the same access controls need to be followed in this particular setup also. Also, metadata needs to be managed. So, if you don't know what metadata is, I've taken a video on that separately. You can take a look at that. There are also videos I've taken on data quality. You can view that also. The next one is interoperability. So when there is a need for combining data, integrating data from multiple business domains, unless the data is in a standardized format, only then you can join. If each team is going to maintain different formats and standards, merging that data, joining that data, integrating that data becomes very tough. So every team needs to follow a common rule and standards, so that when you need to integrate this data, join and merge this data, interoperability becomes very seamless and easy. And apart from this, every domain needs to maintain certain validations and documentations as per the universal governance. So that's about federated governance. So in short, this central repository, different issues related to the central repository management was overcome by this data mesh concept, where every business domain, they are the right experts because they know their data. They know exactly how their data is going to work, how is that data needs to be managed. So that ownership is being distributed in one way. That ownership, since it's distributed, teams can manage their data well. They don't have to take think about too much of infrastructure, as well as access controls, governance, everything is followed. So in that way, accessibility, availability of that data and other things become very easy. So I hope that this video was informative. You got some idea on what data meshes are. So if you found this helpful, please do give this video a thumbs up. If you haven't subscribed to my channel, please do subscribe, and also do share your feedbacks. Thank you.